All right. Yeah, hey everybody. I'm Rob McEwan, co-founder and chief revenue officer with KorrAI Technologies. We're based out of Halifax, Nova Scotia. So you guys need to update your MICA map there. There's no data point for Nova Scotia yet. Today we're going to be talking about Trail. This is our risk agent for infrastructure and logistics, or otherwise known as an AI worker for mining and infrastructure. So I think Doug put it pretty well here. Canada needs mining. Mining needs Canada. We have tons of untapped resources. We have tons of known resources. Capturing and expanding our mining footprint in Canada is really critical for both our national sovereignty, our presence in the world stage, and I think events over this past year have highlighted that in a tighter focus than really any time in my memory, in my lifetime. That's for sure. At KorrAI, this is not a new space for us. So we currently monitor ground motion hazards for about $100 billion in mining and infrastructure assets. So we do that with satellite-based technology and sensors on the sites. But there's a looming crisis in mining, and that is a shortage of skilled professionals. So we know that by about 2030, we're going to need to fill about 80,000 jobs. And the professionals that we need to actually fill those jobs are just not being filled. We don't have enough people that are going into the industry. We don't have enough people that are training to fill these roles. So we need a solution. So how do we actually do that? How do we source these qualified and skilled professionals? Where do they come from? So just mentioned, we're not filling the funnel with the trained professionals to do this, so it has to come from somewhere. Our vision for this is AI coworkers for mining. And this is where I'd like to introduce our product, Trail. Trail is an AI worker that's purpose-built for mining operations. So this is one thing that it stands out to me so much, and I think it really captures the problem that we're trying to capture here. And I've heard this time and time again. People talk about in very senior positions and mine sites and in the industries that support it. I spend about 60% of my time reviewing different reports and aggregating the relevant context. And this goes across, again, engineering side, from people in government, from, trying to get permits through. That exchange of information is just a huge bottleneck when it comes to pushing projects forward. So what we're providing is industry-grade intelligent coworkers. So what we mean by that is, everyone's familiar with large language models, things like ChatGPT, and some of the issues, the opportunities, but also the hazards that are associated with using these types of tools. And a big one is things like hallucinations. So how our system is different is it allows us to insert information. It allows users from different personas. So say chief executive officer, a mine engineer, to query the system that is a localized system that captures their projects. But what's different about this is it allows you to actually trace the source from the documents and trace the source of the data. So it's not just documents, right? It's documents, it's data, it's context, but it also has that traceable flow. And how do we know that it didn't just make this up, right? How do we know that querying the system didn't just give us a hallucination? So the underlying infrastructure is a graph system. So what this does is it maps out all the different ontologies on your mine site. So how your tailings dam is associated with, the underlying or the connected watersheds, how those reports categorize and talk to each one of or describe each one of those entities on a site, and allows you to immediately search through that connected system and then find the relevant context and then bring you right to that document. So it brings you to the document, it brings you to even the page within that document, so you're not hunting through all these reports, you're not hunting through all this context and wasting time. But ultimately what we're trying to do here is to be able to predict tomorrow. What we're trying to do is be able to forecast those hazards in the future. So if today what you can answer with Trail is, what's the current status of, let's say, slope failure on one of my dams, what's been captured, what's been observed, what was looked at and reported on over the past year. Tomorrow, what we want to be able to answer is, given a 1 in 100 year rainfall event, what is the probability of my dam failing? how is that going to be captured through all the different interconnected relationships with rainfall, groundwater, soil types, and so on. So if you like what you're doing, follow the trail. Thanks, everybody.